The flashlight can illuminate any situation. But the first version, invented in the late 19th century, wasn't all that efficient. It produced only flashes of light, so it was named flashlight. This invention soon proved to be more than just a flash, but the name stuck. The flashlight shows us the way when things look dim. To make a military flashlight, they place an aluminum bar in a computerized lathe. Blades go to work and shape it into a flashlight body. As a drill hollows out the bar, coolant flushes over it to prevent the metal from expanding as the tooling heats things up. This blade cuts threads on the outside so they can screw on a lens cap later. A gripper now pulls out the tube so tools can work on the back half. A blade slims that section down and then carves a cross weave onto it. This heavy texture will make the flashlight easier to grip. Next, they drill a hole in the flashlight's tail stud. It's an attachment for the wrist strap. After the flashlight body has taken shape, they give it a black protective coating. Next, using tons of force, a machine injects hot plastic into a mold which forms the lens for the flashlight. They place the lens in a jig and unscrew the mold core. The core has formed threads in the lens so it can be screwed onto the flashlight body later. They use another injection mold to make plastic flashlight bodies. The plastic flashlights are for more general use than the aluminum ones. For custom orders, they stamp a logo onto the flashlight using a hot foil press. Next, they insert light-emitting diodes into a circuit board. The diodes are electronic lamps that are very bright and can be used instead of traditional incandescent bulbs. They solder the diodes' lead wires to a circuit board and then trim them with snippers. The diodes are now secured and connected to the circuit board. For bigger flashlights, they use a lot of diodes, up to 60 of them for this flashlight that's being made for search and rescue work. Next, a stamping press shapes the bronze battery contacts. An ultrasonic welder bonds them to a plastic plate. Then they solder a wire from the diodes to the contacts. The lamp part of the flashlight is now built. Now they insert springs into the aluminum flashlight bodies. They load the batteries, and the springs hold them in place. They slide the lamp assembly into the flashlight cavity and screw the lens on. This aluminum flashlight has just been put together in a flash. They move on to the plastic flashlights. The battery contact and spring assembly goes in, followed by the batteries. The light-emitting diode lamp is next. They screw the lens onto the lamp. The plastic glare shield is the final touch. And now these flashlights are ready to shine. Mention strobe lights, and perhaps the 70s disco comes to mind. But you find strobe lamps, the proper term by the way, on aircraft wings, in those red and blue lights on police cars, and on towers and tall buildings to warn low-flying aircraft. They even play a role in photography and on factory production lines. A strobe lamp emits repeated flashes of high-intensity light. At this factory, production begins with glass blowers. Using a ribbon burner, they heat glass tubes to 1600 degrees Celsius. This softens the glass for bending into a specific shape. At the same time, they blow air through a rubber hose attached to one end of the tube. A cork in the other end traps the air inside. This builds counterpressure to prevent the tube walls from collapsing inward as the glass softens. The size and shape of the glass tube varies by model, but its job is always the same: to house electrodes, lead wires, and xenon gas. The electrodes conduct the current, which charges the gas with electricity, making it illuminate. This factory makes several strobe lamp models, some in large quantities for the mass market, others in small quantities, custom designed for specific clients. With mass-produced models, after glass blowing, automated machines take over. Custom orders are handmade from start to finish. Workers make even the electrodes manually. They weigh a precise amount of metal powder and pour it into the cavity of a press that's similar to what pharmaceutical factories use to make pills. This powder is a blend of several different materials, but the company won't divulge what they are. The press applies 4 tons of pressure, compressing the powder into a pellet. The factory inspects every pellet to ensure it meets quality standards. The pellets then undergo a process called sintering. They bake for 9 minutes in a hydrogen-fueled oven, hydrogen being one of the hottest types of fuel. The 1700 degrees Celsius heat fuses the powder particles into a solid unit that won't crumble apart. Next, they weld a lead wire to each electrode. Insert 2 electrodes, one for the positive current, one for the negative, into each glass tube, then melt that end of the tube closed. Then they attach a wire called a trigger lead. It works like a car's ignition, prompting a transformer to send a high-voltage electric pulse to the electrodes, illuminating the gas. This automated machine assembles the factory's mass-produced models. Before starting it up, workers load the components: a pair of electrodes made by an automated pill press, and the glass tube on top. Now the machine takes over. It vacuums out the air in the tube, then injects xenon gas, then melts the glass tube closed under the electrodes, then cuts off the excess glass. The tube's interior must be completely free of contaminants for the gas to illuminate. So just before the vacuum fill and seal operation, a hot coil encircles each tube to burn away any impurities. On custom-made models, workers do all these steps manually. The strobe lamp is finished and ready for installation. This model is for those warning lights you see on tow trucks and road construction vehicles. It goes into a glass reflector lined with metallic film. A transformer regulates the voltage. Its 3 wires connect to the positive, negative, and trigger leads protruding from the lamp. A glass lens cover seals and protects the lamp within the reflector. Another use for a strobe lamp is in a stroboscope, an industrial device that factories use to perform quality control inspections on high-speed production lines. Once you calibrate the light pulses to the right interval, they visually stop the action so that cameras or workers can examine the goods. The size, shape, and configuration of a strobe lamp's components, along with voltage and other electrical specs, determine how long, how often, and how quickly the light flashes.